Hello, good evening. I welcome all of you to the 56th lecture of ASC webinar series. And we are having today with us Anil Devara as a speaker who will be highlighting us about one of the most important events in the Indian prehistory and how this shaped the human settlements in various parts of the India. And I would now request Purva to introduce the speaker, then Anil can take over. Purva?
Sure, sir. Thank you. Good evening, everyone. Welcome to the 56th lecture of ASC webinar series. It is my privilege to introduce Dr. Devara Anil. He is an assistant research professor in the Department of Earth Sciences, Indian Institute of Technology, Gandhinagar. His research interests include Paleolithic archaeology, field archaeology, luminescence chronology, paleoenvironmental reconstructions, paleontology, lithic technology, and geoarchaeology. He is the recipient of the Early Career Grant awarded by the National Geographic Society, the Dissertation Fieldwork Grant by Renner Green Foundation, the Research Grant by Leakey Foundation, and Small Study and Research Grant, Nehru Trust, for the Indian collections at the Victoria and Albert Museum. For today's webinar, he will discuss the curious case of the youngest Toba Tuff in South Asia. Before we delve into the interesting discussions, I extend my heartfelt gratitude to the professor for sharing his expertise with us through this talk. Sir, could you please begin with your presentation? Thank you.
Yeah, thank you, Purva. Good evening, everybody. First of all, thank you for giving me this opportunity to talk about one of the most interesting topic to me right from the beginning of my doctoral research. In this talk, I'll be discussing about the issues about a volcano that was erupted at around 74,000 years ago, which is situated in Indonesia, northern Sumatra in Indonesia, which is called as Toba volcano. And when it is erupted and what happened, what is the impacts of this eruption on the climate and also hominid behavior, and then what is the relation of this volcanic eruption to the South Asia, particularly the South Asian prehistory or the South Asian Paleolithic in general. Those are the issues that I'll be discussing. Before going into the Toba volcanic eruption, let us look at why studying this specific Toba eruption actually become a very popular, or it's what is the relation of this volcanic event or the super volcanic eruption to the hominin behavioral evolution, or in general the human evolutionary studies. It is actually started during the Cold War time, that is the late 70s or the early 1980s, where you have the Cold War that is going between the two big nations, America and Russia, where there is there is an issue of atomic bombs. If there is an atomic bomb explosion, then how does it actually impact the global populations? To estimate the kind of impact probably these atomic bombs will have on the global populations, you need scientists that actually started searching for the analogies. Do we have any such kind of catastrophic events, or the naturally happened catastrophic events that are in the past, and then what kind of impacts they had on the climate and also the hominin behavior? For those analysis, they started searching, and then they came across this famous Yellowstone national park in US, and also the Toba volcano is situated in the northern Sumatra in Indonesia. These are generally described as super volcanoes. Super volcanoes are generally described as they have a magnitude of around 8 or more than 8. They are generally considered as the super volcanoes. So, but the Yellowstone, it is generally have going back to 10 millions of years, and the latest eruptions, they goes back to 1.2 million years or the 600,000 years ago, where there is no evidences of humans in the Americas by the time. We know that the humans in America only appear very late in time, that is going back to around 15 kilo year, or the fag end of the Pleistocene epoch. But so that time, the Yellowstone, you have the recorded eruptions in the past, but there is no human presence at the time. So the only other eruption that you have in the late Pleistocene, or which is erupted when there are humans migrating or dispersing into various corners or the various places in the earth. You have this Toba, which is erupted around 74 kilo years ago. So you want to get more detailed information about this super volcanoes, you can go through these two sensationally described BBC TV series, documentaries that are generally broadcast in the early 2000s, which will give you a fair idea of what was these other volcanic eruptions and their impacts and all. You can get them. That is what the studying about the Toba become more predominant, and that is how it actually comes into become part of the prehistory, world prehistory, or in fact in Indian prehistory as well. Before going into Toba, let's look at, do we have any recorded volcanic eruptions in the past, historical time, so that we can compare these, because 74 kilo year or 75,000 years ago, we do not have any recorded histories. That is all the research that is being done, trying to understand the impacts of the Toba volcano. But do we have any historical eruptions? Yes, we do have two historical eruptions that were recorded in the history. The one is the Tambora eruptions, which is again situated in the Indonesia, which is erupted in the 1815. Because of this eruption, 1816, the next year after the eruption, you have a generally described as a summer, a year without a summer. So because of these eruptions, the temperature, the global temperatures are actually reduced to around 3 degrees Celsius, which is causing kind of winter, prolonged winter without. That is was the described as a year without a summer. That is the impact this Tambora eruption had on the global climate. The other one we have is not multiple decades ago, around 60 years ago, 30 years ago. It is in 1991. The volcano called as Mount Pinatubo, situated in the Philippines, also erupted. In this image, you can see that the decrease of sulfur dioxide aerosols into the stratosphere. This is the first week of the eruption, and then gradually at the end of this image, you can see the week 12. You have the distribution of this sulfur dioxide aerosols across the globe. This is the kind of impacts the Pinatubo also had. This is also said that after the Pinatubo eruption, the world global temperatures are actually decreased to around 1 degree. These are the two historical eruptions that we have in for the reference to estimate to the Toba volcano. This is where the Toba volcano is situated in the northern Sumatra in Indonesia, and then it is actually erupted 4 times in the last 2 million years. The first eruption is at 1.2 million years, and the second one is at 8.8 million years. The third one is at 0.5 million years, and the latest one, the youngest one, is what of our interest, that is happened around 74,000 years ago. These three early eruptions, they do not have that much magnitude as the latest eruption. That is why you don't see the ash that belongs to these three eruptions generally beyond the Indonesia, or the few kilometers surrounding the Indonesian islands. You don't see beyond that range. But the YTT, you do, it's actually widely spread in the entire globe. This is how the current images of the Toba volcano. I mean, when it is erupted, it is actually formed a huge lake, which is called as Toba Lake. Generally, these volcanic lakes are called as calderas. So this lake actually measures around 100 kilometer in length and 35 kilometer in width. This is a huge lake that was formed because of this volcanic eruption. And then after this volcanic eruption, it was assumed, it was studied based on the sea core records and also the ice core records, that there was a decrease at around 3 to 5 degrees of Celsius, degrees of temperature was decreased in the global temperature. That is what it has been estimated from one of the Greenland ice core oxygen isotope values. As you can see it here, this is indicating the temperature fluctuations in the last late Pleistocene, or in the last 120,000 years ago. This is where the Toba event is actually recorded at around 74,000 years ago. You can see there is a sharp decrease in the temperatures. I mean, you have this side of the graph, you have the cold phases, and this side is the warm phases. You can see that there is a drop in the temperature after the volcanic eruption, which is causing a kind of volcanic winter. That is what it has been termed as. And this volcanic winter, what kind of impacts it has on the populations? We know that there is a decrease in the temperatures. So this decrease in temperatures, how does it actually reflect in the hominin behavior? For that, scientists actually turned into genetic studies. This is the iconic study that was published in 1992 by Rampino and Self, estimating that the decrease in the global temperatures at around 3 to 5 degrees Celsius in the global temperatures. Followed by this, the genetics actually suggested that there is a population bottlenecks are actually happened. So what is this population bottlenecks? So where you have before this event, before this Toba event or any catastrophic event, this is the large genetic diversity that is existed in the populations. Because of this event, the catastrophic event, the large genetic diversity was actually decreased to a small number, and from that number, the post catastrophic event, you have again the increase in the genetic diversity. Since because this later genetic diversity is coming from a small narrow place, you do see a very small diversity in terms of the genetic population that has been observed by the genetic studies that has been done in the later part of the 1990s, suggesting a kind of population bottlenecks, which has become more popular in the later part of the 1990s, which was proposed by Professor Stanley Ambrose. This is what the impacts of the Toba eruption that had on the world populations, by possibly going into the near extinction of the Homo sapien populations or any other archaic Homo sapien, archaic hominins. They become almost the extinct, and then from there they actually become evolved into the later population that we had now. This is what it was done in the late early 1990s. Post that, there is a huge number of researchers started looking into these volcanic ash deposits across the world, mostly concentrating on the Indian subcontinent and also other adjacent regions of the Southeast Asian islands. This is in 2002, after the volcanic winter and also the population bottleneck hypothesis. It was estimated that this is one of the second largest explosive eruption that we had in the last 27 million years. Not even the last 2 million years, but in the last 27 million years, this is the largest explosive eruption that you have, which is estimated to be at around 800 cubic kilometer of dense rock equivalent. This DRE estimation is nothing but how much of rock was actually blasted into the atmosphere, or blasted by this volcanic eruption. Generally, it's generally measured in the cubic kilometers. So in 2002, it was estimated that the Toba was actually erupted at around 800 cubic kilometers of dense rock equivalent. That is, in 2008, it was actually decreased or estimated to be around close to 1,000 cubic kilometers. Earlier, it was 800 cubic kilometers. Now it is 1,000 cubic kilometers. This map actually essentially shows you the comparison between the two known historical eruptions that we discussed earlier, that is the Pinatubo and also the Tambora. The Tambora eruption, which actually caused a year without a summer in 1816. You look at the magnitude of this Tambora eruption, and then look at the magnitude of the Toba eruption. So, what kind of impacts? Even this small event, caused a kind of a year without a summer. Then how about this Toba? What kind of impacts could have Toba had on the global climate and also the human behavior at the time, that we can estimate by looking at these images? This is in 2008, but when you move on to 2013, they actually discovered this cryptotephra, the small glass fragments that are originated from the Toba caldera in the eastern part of Africa. There's a Lake Malawi at the bottom of the Lake Malawi. They actually drilled some cores. Within that core, they found this cryptotephra that dates back to 74 kilo year or the 74,000 years ago. Then the estimations of this DRE is close to double than the earlier estimations, going back to around 2,000 cubic kilometers of dense rock equivalent. That is in 2013, and very recently, I mean, after the 1 year of that, 10-year decade ago, you have this volcanic ash, again the cryptotef fragments, the glass fragments, are actually identified as far as southern tip of southern Africa, the coastal cave sites, the coastal archaeological cave sites that you have at the southern tip of Africa, southern part of Africa. You have these cryptotephra fragments that has been identified from the sediments associated with the archaeological material. Then it is assumed, that it is estimated, that the Toba volcano, the dense rock equivalence of this Toba could be greater than 2,000 cubic kilometers, probably close to 3,000 or 2,800 cubic kilometers of ash that has been, cubic kilometers of dense rock that was actually blasted into the atmosphere. That was the recent estimations that you have, but the search is still on. Probably you may get these volcanic ash, further beyond the Africa as well in the future. So this DRE is nothing but, if you can assume, if you can imagine that you have around 3 to 4 kilometer height, and then of a mountain, 3 to 4 kilometer height, and then you have a base width that is going back to around 40 kilometer of base width, and a conical mountain like this, which is around 4 kilometer in height. So that kind of mountain, that is probably half of the highest peak that you have in Himalayas. That huge mountain was actually blasted into as an ash into the atmosphere at the time of the volcanic eruption. That's what the DRE meant. So this is what the DRE, or the impacts of this Toba volcano, is increasing as the researchers getting new sites, discovering new sites with the cryptotephra and also the volcanic ash as well. So this is what it is. These African evidences not only they actually increased the DRE, or the magnitude of this Toba volcano, but also challenged the earlier conceptions or the earlier hypotheses that we have regarding the impacts of the Toba volcanic eruption. Earlier in 1992, where this population bottlenecks or the volcanic winter was actually suggested, saying that the Toba actually caused huge impacts on the hominin behavior or in the climatic fluctuations. These two East African sites actually says otherwise. The Lake Malawi, you do not have any changes in the climate, any changes in the environment that is associated with these cryptotephra. Same as in the case of the South African site, that is the Pinnacle Point site, where you have the volcanic ash, the cryptotephra, and also the archaeological remains. You do not see any changes in the sedimentary structures or the sedimentology, and also you do not see any changes that are associated with any of the archaeological material that is before the eruption and after the eruption. It seems that human populations actually thrived or continued to live in these areas, in this part of the world, at the time of the eruption, before the eruption, and through the eruption, and also the after the eruption. However, considering the geographical distance that you have, Toba is situated around 9,000 kilometers from the South African sites. So you can also think of very minimal or the no impact of this volcanic eruption on the South African sites. So probably you can estimate that the regions that are very close to the Toba, geographically close to the Toba, could have experienced much of disturbances caused in the climate and also hominin populations as well. This is what generally you have the YTT studies across the world. When you come to India, the first volcanic ash deposits were discovered in India by Desmond Clark and also Martin Williams in 1980s and 1981-82, when they were actually doing explorations, prehistoric explorations in the Middle Zone Valley. They came across these a volcanic eruption, ash, and then they actually geochemically fingerprinted and then attributed it to the YTT. Followed by that, people from Geological Survey of India looking at these, discovering more sites across the peninsular India, followed by other researchers from universities, for example, Deccan College, where they have studied the Bori and Morgaon ash in Maharashtra. So likewise, you have from that onwards, 1980s onwards, till now, we are searching. Researchers are actually actively participating in discovering this ash and dating them and trying to see the impacts of this volcanic ash, volcanic eruption on the hominid populations and also the climate. It was also estimated at the time of the eruption, soon after the eruption, the entire subcontinent was actually blanketed with a 5 to 10 centimeter layer of volcanic ash, the entire subcontinent. That's what it was assumed, it was said. So after that, after the initial primary ash fall through the wind, and then it was actually removed from this original context by the rivers during the monsoon seasons and actually deposited into the alluvial settings, alluvial stratigraphy. Generally, you can see in any of the peninsular Indian rivers. If you go to any of the river valleys, generally in peninsular India, you do see these ash that is coming from Toba eruption sandwiched between the alluvial sediments very well in peninsular India. These are the general distribution of these located volcanic ash sites in India, and also Indian Ocean Sea. You have in the Arabian Sea coast as well. How does it actually links with what is the relevance of this YTT or the Toba eruption to the Indian subcontinent? Anyway, you have this the impacts of this volcanic eruption on the populations and also the climate. Apart from that, it was also seen as a marker, as an isochron to understand the Homo sapien migrations to South Asia. So there are two contrasting theories regarding when actually the Homo sapiens first appeared in this region or in the South Asia. One is suggests that actually Homo sapiens migrated to India before the eruption, and they actually survived the eruption. There is no impacts of this volcanic eruption on the Homo sapien populations. That is following a land route by carrying the Middle Paleolithic technology. That is what the one theory that we have. The other contrasting theory is that the Homo sapiens migrated after the volcanic eruption at around 60 kilo year ago, following the coastal routes and then carrying a different lithic technology altogether. So this volcanic ash in the Indian subcontinent is generally seen as a marker for these migrations. Marker as in, if you see a volcanic ash generally in any of the peninsular Indian river valleys, it is generally assumed that that sediment specifically that indicates a 74,000 years ago time range. This is what the general conception that we had before we did some luminescence dating of these associated sediments with the YTT. These are some of the sites that has been studied in the last 2-3 decades in India, studied as in excavating them and trying to understand the relation of these volcanic ash deposits with the archaeological material. The first ones, or the first one as in the Borean Morgaon, they actually stand aside because there are some controversies regarding this Borean Morgaon we have, because earlier the ash from Borean Morgaon, they are said to be associated with the Acheulean artifacts. So Acheulean artifacts, if you're talking about, you are talking about some time frame that goes older than the 74,000 years ago, going back to as old as probably 400 kilo year or the 500,000 years or the half a million years ago. You do have the Acheulean in the Indian subcontinent, where you have this volcanic ash that is associated with this Acheulean culture. It is also indicates that the older time range. And also, interestingly, the potassium argon dates, the dating method that we use to date the volcanic glass, and also the paleomagnetic dating of these sediments coming from Borean Morgaon, they actually indicate a date that goes back to at around 600 to 700 kilo year or 500 kilo year. In that case, it was actually suggested that probably the volcanic ash that you have from Borean Morgaon may belong to the older eruptions, not the youngest eruption. That's what it was assumed in the assumed also. But later on, when they have done the geochemistry of this the ash from the Borean Morgaon, it is indicating a more close affinities, close comparison with the youngest Toba Tuff, which is dated to 74,000 years ago. And also there are some OSL dates that has been done in 2012 and 13, which is also indicating that the last exposure date of the volcanic ash from Borean Morgaon is around 20 to 30 kilo year. That's a controversy that is still, I think, needs some reevaluation re-looking at those studies. Apart from that, the other regions, for example, the sites in Son Valley and also the sites in Jwalapuram, they are actually very well studied, and also they do have a very clear association of archaeology with them as well. Each site we'll see in detail, somewhat detail. This study published in 2009, when they actually contributed to the impacts of the eruption on the climate, global, not global climate, Indian climate. So these three sites, which are situated in the middle Son Valley, where you have the ash deposits here. This is a carbon isotopic analysis of carbonate nodules coming from the sediments below the volcanic ash, within the volcanic ash, and also the above the volcanic ash. What does it indicates here is simply that before the Toba ash or the below the Toba ash, all these carbon isotopic analysis suggesting that there was a kind of forested landscape, or there is a kind of trees that were there before the eruption or the below the volcanic ash that you have from these three sites. If you look at this ash, within the ash and also the post ash, what you can see is that this is more developing or more leaning towards a kind of grasslands or the C4 kind of environments that you do see after the volcanic eruption or the above the volcanic ash. So this study indicates that before the eruption, the Son Valley landscape was a kind of forested landscape, and then when the ash actually fall down on these forested landscapes, and then this because choking the rivers and also contaminating the water, what happened is the forest actually gradually dried up and then becoming into a kind of grasslands. That's what it was suggested by this study in 2009 by Williams et al., suggesting that it actually caused a significant impacts on the climatic on the climate of this central India or the middle Son Valley. This is what it was suggested. But later on, there is no C14, OSL dates for these sections. But later on in 2013, 2014, when they have actually done some dating of these same sections, there is Kunteli, Rehi, and Hirapur, these dates actually comes to be younger than the 74,000 years ago. So these ash layers that what you are seeing here, they are not actually dated back to 74,000 years ago. They're actually later than 74,000 years ago, suggesting that this is actually probably redeposited. So the kind of analysis or the kind of interpretations that you have regarding the climate so may not be applicable to the 74,000 years ago, because what you're talking about the time frame that is several thousand years after the Toba event. So may not indicate may not reflect a true or the actual time range of the volcanic eruption or the volcanic ash. This is one of the study that we have regarding the climatic fluctuations, and then the issues, the chronological issues that we have associated with this section. And the second important study that we have is the Jwalapuram, which has become more popular because of this. It's a very good association of this volcanic ash, and also the very well preservation of this volcanic ash associated with the Middle Paleolithic technology in Jwalapuram. Here, it was said that there is a Middle Paleolithic technology or the populations that is practicing this Middle Paleolithic technology prior to the volcanic eruption, and they actually post volcanic eruption as well. Here in this case, particularly Jwalapuram 3, if you can see it here, you have a date of 77 kilo year, that is the below the volcanic ash with a Middle Paleolithic technology, and you have above volcanic ash, you have a date of 74 kilo year with a Middle Paleolithic technology as well. So suggesting that there is no change in the technology, that means that the volcanic eruption does not have much of a impacts on the hominin populations. If you see the climate, impacts on climate, typically what happens when the volcano actually erupts? Volcano erupts and it actually comes up with huge amounts of ash, which is actually covering the atmosphere and actually stopping the reflecting the sun rays, causing a kind of volcanic winter, decreasing temperatures, and also it contaminates the water. You cannot able to drink the water, and also when the animals actually they inhale these volcanic ash glass shreds, they actually damage our lungs as well. So you can see the animal populations also gradually decrease in the landscape. So you have limited resources, no animals, contaminated water. You do also expect that some kind of change in the hominin behavior as well. But that is not reflected, that is not seen in the Jwalapuram case, where you have a continuous occupation of this middle Paleolithic people in Jwalapuram before the eruption and also the after the eruption as well. This was the kind of interpretations that we had when this research was actually published. But in 2012 and 2010, that area, these OSL ages, the ages that you are seeing here, they're all luminescence ages. So these luminescence ages are actually revised to be younger than the 74 kilo year. This is now this date that you see from Jwalapuram 3, that is the post YTT, it is now younger than 55. I mean, there's no publications as such, but it was mentioned as by Petraglia et al. In 2012 in one of the paper. They himself mentioned that it is actually younger than the 70, younger than the 55 kilo year. So that means that is already 20 kilo year beyond the younger than the volcanic event. Younger than means it can be 30 kilo year, it can be 40 kilo year, it can be even younger than that as well. This is what the issue that you have with the Jwalapuram as well. Apart from this 2012, there is another paper which actually who done the luminescence dating of these Jwalapuram sections. Jwalapuram two localities they have dated. Those dates also indicates that these all the volcanic ash and above the volcanic ash dates, they are all very younger, going back to around 30 to 25 kilo year, not very far away, temporarily far away from the actual event that had happened in the 74 kilo years. So here there is no climatic reconstructions that we can see from Jwalapuram. It is entirely based on the continuity of the lithic technology. But recently, I think few months back, there was also another paper by Jha et al. They are suggesting that there is a desiccation events that had happened after the volcanic eruption in the Jwalapuram section. The same sections they actually done some studies, but they also potentially ignore the chronological disputes or the chronological complexities that you have in the from the Jwalapuram. So they not indicate the actual primary ashfall. They're indicating they're actually you are actually studying, you are actually looking at a secondary or the redeposited ash from this context. Followed by this, you have another site in Daba where there is no actual volcanic ash deposits, but they have this volcanic cryptotephra that has been identified. And here also it is suggested that you do see a continuity of lithic technology or the continuity of human occupation of these landscapes through the volcanic event or the YTT deposit, suggesting that there is no or the very if there are impacts also there are very minimal negligible impacts or there is no impacts at all of the volcanic eruption on the South Asian populations, because you do see a continuity of behavioral hominin behavior through volcanic eruption. This is what the Daba actually suggests. So within this background, we looked into one of the region that is situated in the southeast India, that is located in geographically, politically located in the southern Andhra Pradesh, which is very rich in Paleolithic sites, and also in 2005 and 2004, even prior to that, 1995, 1996 also, there are some reports of volcanic ash coming from many of the river valleys in the southern Andhra Pradesh or the Rayalaseema area. So we did some research exploration, surveying in this area, and we come up with new sites that are bearing both the volcanic ash that belongs to YTT, which was geochemically fingerprinted, and also associated with the archaeology as well. So in two of the sites, we actually conducted some excavations or the section scrapings, and then tried to date these sections, and also try to extract the archaeology from this region as well. So one of the site that is situated in the upper reaches of this Gundlakamma river basin, that is in the close to Nallamalai hills. This is the site known as Ratlapalle. which we conducted some step trenching and also done some OSL dating of these sediments that are both overlying and also underlying the volcanic ash deposits. We have conducted this dating in PRL lab in Ahmedabad. So we have dates that goes back to 76 kilo year for the below volcanic ash, and above volcanic ash you have a 64 kilo year, and in between these two dates you have around 1 meter thick sediment which is not dated, because at that time there are no not enough protocols to take the volcanic ash itself using the luminescence technology. That is why this particular section was not dated using the OSL technology, the luminescence technique at the time. But there is a 1 meter of sediment gap within this, probably which is also comprises the actual event or the immediately after the volcanic event. The sediments, you can see it in the probably in this in this section or in this site. You have artifacts, archaeology that is not closely related with the volcanic event, but you have middle Paleolithic artifacts that actually goes back to 140 kilo years from this particular section. But there is no archaeology that is immediately linked or immediately associated with the volcanic ash or the YTT in this site. But you have artifact that goes back to 140 kilo year that has a nature of middle Paleolithic, or the middle Paleolithic. You have the late middle Pleistocene. But if not from this site, but around this landscape in the upper Gundlakama river basin, you have at 7 to 8 places we have reported the YTT, and also very rich archaeology as well. So we have done some composite stratigraphy by recording multiple sections at different places and trying to correlate with these sections using this volcanic ash as a marker, and also the other associated archaeology. We have come up with this kind of composite stratigraphy for this section, where you have YTT, you have below YTT and above YTT. So not from this Retlapalli site, but other sites in this river basin, you do have archaeology associated with this unit and also associated with this unit D as well. This is not coming from this specific site, but several other sites that are actually distributed across the across this upper reaches of the Gundlakama river basin. We have that composite stratigraphy. What does archaeology indicates prior to the eruption and the post eruption is that this is the kind of archaeology that you can see, or this is the kind of lithic technology that you can see that is associated with the sediments that are underlying the volcanic ash, or you can say before the volcanic eruption, which is indicating a kind of typical middle Paleolithic technology with the prepared cores. You have other scrapers and all, and then followed by that you have this lithic technology that is post eruption, or the sediments that are overlying the YTT sediments in this region generally. So this is also again indicating a kind of middle Paleolithic technology with a very rich presence of levallois, varieties of levallois, and then scrapers, the other toolkits as well. And then based on our observations, we are saying, we're interpreting this as there is no change in lithic technology from what you see in this slide and what you see in this slide, or generally below and above YTT, there is not much of a changes that you can see in the lithic technology, except you do see some kind of laminar elements that is becoming more predominant in the post YTT sediments. But in the pre YTT sediments, you don't see that much of a preference of the elongated artifacts, as in the blades, not typical blades, flake blades, kind of things. Apart from that, there is not much of a change that you can see between the technology prior to the eruption and after the eruption, which is also corroborating the evidences that you have from Jwalapuram and also Daba as well. This is the site or the scenario that you have in the Gundlakama River Basin. If you move further south of Gundlakama River Basin, that is around 90 to 80 kilometers further south of that area, or the southeast of that area, we have another river basin known as Manniru River Basin. Here also you have a very rich archaeological sites that is spanning the late Pleistocene, and also volcanic ash deposits as well. In one of the sites, we have conducted excavations as a part of the Venergan funded grant. Here, one of the trench, we also came across this volcanic ash, that is the trench 2. This This is the picture of the trench too. As you can see, the YTT has a very distinct layer, in whitish in color. If you look at a closer photograph, again, this is what the volcanic ash, which you can easily distinguishable or identifiable from the other sediments. And then we also done some dating, luminescence dating of this particular section from below the volcanic ash and above the volcanic ash, and within the volcanic ash also we have done we have two dates coming from two different protocols. So all these dates are indicating that this volcanic ash probably redeposited or deposited at around 30 kilo years ago, so 30,000 years ago, which is younger than the actual eruption event, that is at 74,000 years ago. That is around 44,000 years of gap that you have from the initial eruption, initial ash fall, and these redeposited volcanic ash at this particular site, which is giving dates of 30 kilo year. So this is what the issue that you have with this particular site. These two sites, they are in a single river valley. I mean, a geographically single small area, 80 to 90 kilometers, but still they are showing a huge contrast when it comes to the depositional or the redepositional processes that you have associated with the YTT. At one site, you have a very pristine ash or the luminescent ages that is going back to very close to the time of the eruption, that is around 74,000. Whereas in this particular site, you have the dates of this volcanic ash that is going almost half of the timeline, that is 44,000 years after the initial ashfall. So we did some sedimentological analysis trying to understand what actually caused this redeposition. If you are assuming this is a redeposition, let's say, yeah, not assuming, you have to think of this is only redeposition. Otherwise, at this time range, there is no other eruption of Toba that had happened. That is 74 kilo year is the last eruption that had happened. After that, there are no other eruptions from the Toba, so you cannot possibly think of that. So the only remaining scenario is redeposition. So if it is redepositing, just assume a scenario that you have a initial ash fall after the volcanic eruption. The wind is actually carrying the ash from Indonesia to this area, and then it is falling on the ground. And then immediately, if it is buried, you can see very thin, 5 to 10 centimeter thin ash layer in the sediments. If it is redeposited, you do see a slightly thick deposits. If it is after several thousand years, if it is redepositing, so it's obviously we expect it to be mixed with the other sediments. The sediments that are there in the surrounding, it has to be mixed with the other sediment and got deposited other places. In that case, you are not expected to see these kinds of pristine ash layers, as in whitish colored, a completely distinguishable as a distinct sediment. You cannot expect. If it is redepositing, it has to be mixed with other sediment and it has to lose that pristinity and the whitish color, and then got deposit with another color. But that is not the case in this scenario. You can clearly demarcate this volcanic ash in this particular section here with ages that are very younger than the actual event. So to understand this, why this is happening, what could be the possible depositional processes that we have, we tried to answer that by using the sedimentological analysis, by doing the mineral magnetics, the grain size analysis. We expect to see if there is any different patterns that you can see in the depositional process. But both the mineral magnetics and grain size analysis, they are not indicating much of a difference throughout the sequence. At least the below YTT, below ash layer, and above ash layer, these three layers, they do not show any kind of drastic changes. It seems to be a kind of single event, which is also suggested by the luminescence areas as well. If there is a disparity, if there is a disjunction between these units, that should actually reflect in the luminescence edges, but it is not reflecting in the luminescence edges. They are suggesting that all these three layers, they are actually deposited in a short time span. There's not much of a lag between the deposition of these three layers, which is also indicated by the mineral magnetics and also grain size analysis as well. With that, we actually come up with a plausible scenario, a kind of model. How does it could have actually happened? We do not know whether it could be the scenario or not. In this possible scenario, you have a monsoon cloud that is coming from rain, that is situated in the rain shadow regions, and also you have these dust clouds that are also forming or coming from somewhere else or forming there. And then when you have these dust clouds and monsoon clouds, both are actually raining together, and then you have probably this dust cloud contains this volcanic ash, because volcanic ash is very fine in nature. This is a fine silt fraction. So that could have been part could have been the part of the dust cloud, and then together this is kind of forming a kind of bundle deposit. This could have been a possible scenario where you do see this pristine ash, the whitish colored ash, or not much of a contaminated ash that has been redeposited several thousands after the actual event, but still showing this, the pristine color and the texture of it. This could be the possible scenario. And then apart from this, there are also other researchers who also suggested similar kinds of possible scenarios for the redeposition of this ash, which is actually coming from uh, Zone Valley, Middle Zone Valley. In this case, which was published in 2014 by Newdorf et al., what they are suggesting is that this volcanic ash could have been reworked as the process of the fluvial processes or the river processes. It has been reworked probably. If that is the case, then you expect to see a kind of contamination on the mixture of other sediments also with this scenario, which is not observed in the Middle Zone Valley. The other scenario they suggest is that probably this volcanic ash, after the initial deposit, and then it is actually breaking into small blocks, because all these sections that you are talking about are on the bank of the river, the alluvial sections. Probably they're actually breaking into small whitish colored blocks, and then they're redepositing and then becoming part of the younger sediments. That could be another scenario that is what they are suggesting, because the dates that you have from these sediments, they're all younger than the 74,000 years ago, very younger than the 74,000 years ago. That is why they come up with these possible scenarios. The other scenario they suggest is that you have a sediment that is below the volcanic ash, that was actually gradually cut by the river activities or the fluvial activities, and then later on filled by the fluvial sediments, the younger fluvial sediments, where you collect sediments from this and then you date it. Obviously, it will give you a date of the last exposure, but the sediment stratigraphically is below the volcanic ash. So you are probably mistaking or misreading this information, this dates as a as a association with the YTT. These kinds of scenarios that you have from the Middle Zone Valley and our own site as well. If you look at the other dated sites as in the other sites with luminescence ages associated with the volcanic ash in the subcontinent, apart from our sites and also the Jwalapuram, you have the Son Valley sites like in southern Andhra Pradesh, again from the Rayalaseema area, and you have Maharashtra, and also sites from Gujarat. This is the map that actually shows the distribution of sites with the YTT deposits having OSL ages. And if you look at the list of the sites, except two sites, that is Tejpur in Gujarat and Retlapalle, that is in Andhra Pradesh. If you look at below and above the ash ages coming from the underlying and overlying the YTT, at Tejpur we have 74 kilo years for the below ash and 60 kilo years for the above ash. That is also having a kind of a huge gap. But in Retlapalle, it is 76 and 64 with a around 1 meter of 1 meter thick sediment being in between these two dates. These are the only two sites that indicates probably ages that are very close to the volcanic event or the time of the eruption. But rest of the sites, all these sites that you have coming from different parts of the peninsular India, they all have issues with the dates. Either the above YTT dates are very young, or the below YTT dates are very young. Even one of the case that we have in the site that is closely situated with the Retlapalle as well. So this kind of the disparity that you can see across the subcontinent that is associated with the volcanic ash. In this case, that is why we are going on suggesting that wherever you see this volcanic ash, so it is not always belongs to the time range of 74,000 years. So before you use it as a marker, before you use it as a chronological marker, it is always better to get a chronological control and also the depositional control, depositional conditions of this volcanic ash before you actually use it as a marker. Okay, this is the to summarize the issues that you have, the YTT issues. If you look at the impact of this volcanic eruption, it is still contentious whether it has a huge impacts or not, or it's minimal. The impacts are very minimal, or there is no impact. We need to get more paleoclimatic data specifically coming from terrestrial sites. There is a gap huge gap between the terrestrial sites and the sea core and the ice core sites. Because if you look at the sea core or the ocean core or the ice core, there the chronological resolution that you have is a very fine. As in, you can get the chronological resolution going back to even up to decadal level. Every 10 years, what is happening in the climatic history that has been recorded within these ice cores and the sea cores. But when it comes to terrestrial settings, the kind of dating techniques that you have to date these terrestrial sites, be it OSLH or the be it C14H, they have the error margins that actually goes beyond the decadal. You have the error margins goes up to kilo years. But the impact of volcanic eruption or the Toba eruption, it is the time span is very less, probably a few weeks, probably a few days. So getting that kind of resolution within the terrestrial setting is actually very problematic in this context. Unless until you come up with very dating technique that can actually give you high resolution in dating these terrestrial settings, unless until this issue remains as such. And also the several redepositional event of the YTT. It is not a single time. Obviously, the initial ashfall was done at around 74,000 years ago. After that, it was getting redeposited multiple times in the past. It is not a single time. The sites in Son Valley, the sites in Jwalapuram, the sites in Maharashtra, they are getting redeposited not at a single time. They happen continuously probably, or happened at multiple time ranges associated with or probably driven by the localized environmental settings or the localized depositional settings. So to understand those localized depositional settings, you need to look at these volcanic ash sediments that contain this volcanic ash. You need to approach them with chronology, and also you need to approach them with the sedimentological analysis as well. If not as a 74,000 kilo year marker, these ash deposits, they can also tell you something about the local depositional histories as well, the local climatic fluctuations as well, as in the case of Motraval Podu. So we are thinking of something that is related to bundle deposition, where you have the dust cloud and the monsoon cloud coming. If that has to be true, so such kind of imagine that there is a dust cloud and the monsoon cloud coming and then getting deposited at that place. If that is not ash, just imagine if that is not ash, then that event, the bundle deposition event is very difficult to identify. So in that case, probably the YTT can be, can be used as a marker to identify the localized depositional processes rather than using it as a 74,000, a marker of the 74,000 time range. And also, there's a huge gap of association of archaeological material as well. Even though you have hundreds of sites across the peninsular India with the YTT deposits, but hardly very few sites have the direct association of archaeology associated with these volcanic ash deposits. You need to find more sites with a good association of archaeology associated with this YTT as well. And also, there is a lack of chronometric ages. All these ages that you have seen in the previous slides, they're all actually published in the last 6 to 7 years, or probably a decade back. But 10 to 15 years ago, you're getting more dates of these ones. But if you get more dates, because there are sites are hundreds of sites you do have across the peninsular India. And then lastly, there is a lack of high resolution paleoclimatic data. Not even a single site till now. Even though I mean the YTT issue is very, it's interesting and also noted globally, and it has a very good rich YTT deposits in India, but not even a single site you have where you have the paleoclimatic reconstructions using it is either carbonate nodules or the biomarkers or the other phytoliths or any other proxies that you have. You do not have such kind of sediment or the site which yields the climate, paleoclimate before the eruption, through the eruption and above the eruption. Not even a single site that you have, unfortunately. So if you get those paleoclimatic data, chronometric ages, then probably you'll be able to talk more about the impacts of this volcanic eruption on hominid populations and also climate as well. So yeah, this is what it is. This is the lake, the picture of the Toba Lake that you have now currently. These are the acknowledgements, funding, and also the people that who are involved in this research. Yeah, thank you. I'll take questions if you have any.
Thank you, Anil, for a wonderful talk and nicely summarizing the research and clearly highlighting all the very important aspects related to the volcanic event, associated cultures, and the research you are also carrying out, right? Really wonderful to listen to you. I mean, we have some questions in the chat box as well as Q&A box. Can you see? I mean, one is by Charasmita in the chat box. I think you can directly read and answer that one in the chat box. And
Yes,
there,
yes, yeah.
and there is one more
Tools.
question there.
Yeah,
Yeah.
I'll read out the question. Two slides which showed tools, technology might have been similar, but typology definitely looked different. Are these differences statistically valid? If yes, do you have a hypothesis? Why? Yeah, they look typologically, yes, they look different because even using a single technology, even if you have a single site, also you do see different typologies produced by single technology. Statistically, no, there is no such kind of variations between these two type of toolkits we have observed as of now. Why there is no change? Is that what it meant? I guess. Yes, ma'am. I guess it is why there is no change in stone tool technology. It means I don't know why there is no change in technology. Probably the kind of time span that you are talking about between these uh, below YTT and above YTT is very less. Probably you were talking about something going back to 6 to 10 kilo years. So within that short time span, thinking of change in technology, uh, may not be expected. That is what. I hope I answered that.
We
Uh,
have a question in the Q&A chat box.
yeah, I'm reading it. It's absolutely true. Markup, several issues. Okay. Oh, yeah. Yes. There are no questions, right? Is there another
There
one?
is one in the Q&A. If you look into the
Okay,
Q&A,
okay. Yeah, yeah. Hmm. Do we see genetic bottleneck in other species at the time of YTT? So, if you mean other species, as in the other animal species, no, there are no such kind of studies has been done by trying to look at the genetic bottleneck in the animal species with regards to the YTT event. But in Southeast Asian island, that is the areas that are very close to Volcan Toba, that is in the uh, Indonesian islands, you do see some of those animal species becoming extinct, very few of them, and also some of them becoming near extinction. Those events that were there recorded in the areas that are very close or adjacent to the Toba volcano, but not as in the genetic studies. No, it is only limited to the human genetic studies.
There is one more question in the chat box coming up.
Yeah.
But
Is there any site in Eastern India where there is a YTT layer? In Eastern India, I don't remember exactly. Eastern India means you're talking about somewhere in West Bengal or Bihar, that region. I don't remember reading any of those, any of or any of the sites having YTT in Eastern India. It is there in Orissa. You have, yeah, Orissa you have, and Central India. Yeah, I don't remember reading any literature mentioning about the YTT deposits in East India. No. Okay, other question. Genetic diversification after a volcanic eruption is understandable, but why does genetic diversification occur even before the volcanic eruption in a region? So why does a genetic diversification occur? Because that is there after the Homo sapiens emerged at around 300 kilo year. You do, and they actually moved out of Africa and then occupied different areas. So obviously you do expect a genetic diversity when they're moving out and then interacting with other people or spreading into different parts of the world. It is expected, right? When the species formed and then it is evolving geographically, it is extending. It is expected to have a genetic diversity. That genetic diversity was there before the eruption already, and then that was actually decreased because of this eruption. And then post eruption, after the eruption, you do see again the diversification becoming more and more through the migrations and dispersals or the geographical spread of these hominids. Okay, there's an answer. At Burla, you have YTT in West Bengal. Okay, thank you. Another question: what might be the northwestern extent of Toba ash deposits? Also, if there any site that display double deposition of ash layers in South Asia. What might be the northwestern extent? That is in Gujarat. You have this terrestrial record. You have volcanic YTT. In the Arabian course, also you do have the evidences of this YTT. Also, if there is any site that displays double deposition of ash layer in South Asia, I don't understand what is this double deposition. Maybe you mean two different layers in a single site, or you mean very thick deposits. If it means two different distinct layers in a single sediment, no, there is no such kind of two different ash layers that are separated by non-ash layers. That was not recorded. But yes, you do have a very thick ash deposits coming from Jwalapuram specifically. There are few meters of thickness. Maybe some of the sites also goes up to 3 to 4 meters as well. Yeah. Malavika. So YTT should not be considered as an isochrone in terrestrial context. And has YTT been found in a non-alluvial context? Yeah, that is what I feel. I mean, that is what the evidences are actually saying. YTT cannot be used as a isochrone in the terrestrial context. Coming to the non-alluvial context, I mean, if you mean the Aeolian context, no, there is no such kind of evidences that you have. Probably if you do some sedimentological analysis, probably you may find the YTT coming from non-alluvial settings. But yes, in Billa Surgam, they found cryptotephra coming from the cave sediments, not as a distinct layer, but they have some glass threads coming from the Billa Surgam context. That is also published also. Okay, is it because of lack of research or anything to do with the geographical setting that hinders preservation, that we don't have any site with white heat in eastern India. Yeah, see, in the background of the complex redepositional processes that are generally associated with the white heat, it is expected, the geographical disparity in preserving the volcanic ash. Yet it is obviously geographical setting that actually determines the preservation of this volcanic ash. Because after the initial ash fall, it is the kind of monsoon patterns that you have, and then those actually determine the kind of depositional settings that you have in that region. They actually determine the preservation of this ash. Yes, obviously, yeah. Adding further to Charumam's question, could these similarities in tool technology and somewhat in typology indicate the continuity of the same population? Yeah, it could be. I mean, do you mean same group? Not same group, obviously. Same population, yes, could be. There is a possibility. Yes. In our research, do you see that there was a genetic bottleneck of humans due to YTT? I don't do genetic studies. I mean, the kind of the slides that are the information that I shared, it is essentially coming from the literature that has been published right from the 1980s onwards. But I don't generally do any genetics because we don't have even in a single fossil in the Indian context. So I don't do any genetic studies. But there are the huge number of literature that has been published when it comes to genetic bottleneck in that is related to the YTT. Okay, could the abrupt gap at Athrampakam around 74 K be associated to the Toba? Yes, it could be, or it or not, as or not also, we do not know at the moment, because considering the context of this, the background of this, the variation, the diversity that you see, or the kind of debate that you have, whether it caused impacts or not, in that background it could be or it may not be because of this YTT event, because the same time range, if you look at in Jwalapuram and in Dhaba specifically, you do see continuous occupation of the hominins through the 74 kiloyear time range. So it could be probably because of the geographical variations as well. The populations in Son Valley could have been acted as or that region could have been acted as a refugia for them. Probably in Athirampakam, probably it could not acted as a refugia. That is why they had to, you do see the gap. Is there any evidence of abrupt genetic changes in animal populations due to their early response to natural disasters, such as volcanic eruptions, given that many animals are known to sense and react to environmental disturbances in advance? I think I answered this question first. Somebody asked. No, there is no such kind of genetic studies with regards to the animal populations are actually done in the context of YTT. Probably, if you could also see such kind of genetic changes also, but no, that has to be explored. That topic, that region has to be explored to see the genetic variations. But this one, there is an interesting evidence that has been unearthed in Yellowstone that goes back to 10 million years, where you have a huge number of animals died at the same place. And also some pathological studies also done. They indicated some kind of tissue growth on the bones because the excessive inhalation of this glass shreds. That is not related with the YTT. That is related with the Yellowstone volcanic eruption, and they actually inhaled that glass shreds, which is causing the damage to the lungs of those animals, and then they died instantly. At that place, we have a huge number of animal bodies becoming fossilized with evidences of those kinds of lung disease or some symptoms that are related to the lung disease. But the genetic changes in animal populations due to their because of the volcanic impact, that has to be explored. Yeah.
Thank you, Anil. I don't see any more questions in the chat box. And we we come to the end of this talk, and I really thank you, Anil, for this wonderful talk once again.
Thank you, sir. Thank you.
Really a pleasure to listen to you. And I also thank Purva and Manjari for helping in conducting this session. And I thank all the participants who have registered and logged in. I invite you again for the next talk in around 24th of June. I mean, we'll be having the talk early because of the non-availability of the speaker. So I will announce the exact date later on. Anyways, thank you to all of you. And I hope to meet you again. Thank you once again, Anil.
Yes, thank you. Yeah.